Welcome back from a short break, learners. So now we're just going to jump into our first concept of the lesson. That is now the temperature and the particle model of matter. So what do we mean by that and what is it? We need to know that if the motion of the particle changes, the temperature also changes. Remember now we said that all matter is made up of particles that are in a motion, that are always in motion. So now, when we are increasing the temperature of those particular particles, then the motion will also change. So by increasing the temperature, the motion will also increase. And this now leads us to further points out about the particle model of matter, that the motion of the particle increases when temperature increases. So if we have a particular matter and we increase temperature on it, then the particles making up that matter will increase in terms of motion. Yeah? And then now, the motion of the particle decreases when the temperature decreases. So removing the temperature or decreasing the temperature is going to cause the particles to decrease in terms of the motion. So they're going to move slower. That is, if we increase the temperature, they're going to move faster and faster, meaning that the kinetic energy of those particles is going to increase. And when we decrease the temperature, the kinetic energy of those particles is going to decrease. That means that they are going to move slower and slower. Furthermore, if a substance is heated, it expands. So this is what we need to underline. If a substance is heated, it expands because the particles are moving faster and further apart. So once we have matter and we increase temperature of that matter, those particles are going to start moving more faster and faster because there's going to be an increase in kinetic energy. But not only that, those particles are going to expand because the temperature has been increased. They expand because they are going to be moving faster and faster. What we need to note is that the number of particles is not going to change. If we are saying that the particles are going to expand, we do not mean that the number of particles will be increased. The number remains the same, just that the particles, they become larger in size because of the spaces between them. They increase the spaces between the particles. Now, what about now if we are cooling the substance or by decreasing the temperature, what happens? So if a substance is cooled, it contracts because the particles are moving slower and closer together. So now what does this mean in context? We are saying that when we have particles that are inside a certain container and we increase the temperature of that particular matter, the particles are going to be moving faster and faster, and when they move faster, they're going to be moving away from each other. So once they move away from each other, they will appear to be larger. However, the only thing that increases is going to be the space between the particles. So once the space between the particles increase, because the particles are moving further apart, the matter appears to be larger. The particles do not increase in size, they just move away from each other. And then if we are cooling the same substance, now the particles are going to be moving slower and slower and moving closer and closer together. So because they're moving closer together, they contract, meaning that the spaces between the particles becomes smaller and smaller. Then at the end of the day, they're going to cover a small surface area. Then they appear to have decreased in size, whereas they are still the same size, just are closer together. So that's what we mean by increasing the temperature and decreasing the temperature of matter. What happens when a substance expands, and also what happens when the substance contracts. So now, on to our next concept, whereby now we are looking at the expansion and contraction of different materials. Now, what happens when we have different materials? How do they expand, and also how do they contract? To start, have you ever been inside a tin-roofed house? On a hot day, you often hear the metal roof panel groan and creak. Do we know why this happens? So now this happens because the metal roof panels expand and contract. Remember we said expansion happens when there's an increase in temperature. So on a hot day, the sun is up there, it's very hot, so that means the particles making up that roof, they are going to increase. Remember, when they increase, the spaces between the particles, it increases. The particles and the number of particles remain the same. Just the spaces between them that increases. And also, they contract. Remember, when they contract, they are just decreasing the spaces between the particles. So the metal roof panels expand and contract as the outside temperature changes. So remember, expansion, increase in temperature, contraction, that's a decrease in temperature. So when that happens, those particles, those roof panels are going to react to it based on the change in temperature. So when this happens, the panels scrape against each other and against the nails that keep them in place. Then the scraping of metal against the metal causes the creaky groaning noise. So as those particles, or as those roof panels are scraping on the metal against the nails, there's going to be that creaky and groaning noise that you hear on a hot summer day because of the change in temperature. Furthermore, some materials become slightly larger when they are heated. Remember, the substances, the particles, they do not become larger. They just simply move away from each other and therefore appear to be larger. It is because of the spaces between the particles that makes them to appear to be larger. The particles and the panels, they remain the same in size. And also in terms of the number of particles making up that particular matter, they remain the same. So when they are heated, we say they expand. So materials can also shrink slightly when they are cooled. We say they contract. So when we heat that particular roof panel, it expands because the spaces between the particle increases. And when we are cooling down that particular roof panel, the spaces between the particles decreases, and therefore we say they contract. Right. Moving right along. We are now going to be explaining the expansion in terms of the particle model of matter. But before we do that, let's just quickly go for an ad break, and I'll see you just after this.